Good morning, everyone. Welcome to our class in numerical solution to CE problem CE 323. So for today, we're going to discuss Unit 4, Part 2. So this is the continuation of the discussion in roots, determining the roots of nonlinear equations. So previously, we already discussed the introduction to roots of nonlinear equation and some bracketing methods, which includes the incremental search and the bisection. So for today, we are going to discuss the false position method, have an overview in open method, and discuss Newton-raphson method in determining roots of a nonlinear equation. So let's start with the bracketing method using false position method. So the false position method, or the regulopalsy method in Latin, is an improvement of the bisection method. So the two methods share similar procedures, with notable exceptions to obtaining the middle point in the interval. So ibig sabihin lang yan, yung procedure in determining the roots of an equation is the same with bisection method. So parehas sila ni false position. So ang pagkakaiba lang nila is yung formula in determining x sub m, or yung middle point in the interval. So sabi din dito, so the bisection method converges slowly due to its behavior in redefine the size of the interval that containing the root. So the graphical representation of a false position method is shown in the figure. So it shows that the middle point x sub m is the intersection of the line connecting x sub l, f of x sub l, and x sub u, f of x sub u, and the x-axis. So to obtain the numerical value of x sub m, so we are going to consider the equation of the line connecting its endpoints using analytic geometry, that is, using equation of 2-point of a line. So, matatandaan nyo, ito yung formula ng 2-point of a line natin. So, we have y minus y sub 1 is equal to y sub 2 minus y sub 1 over x sub 2 minus x sub 1 multiplied by quantity x minus x sub 1. Kung saan, yung y sub 2 minus y sub 1 over x sub 2 minus x sub 1 natin is also the slope of the line, diba? So, from the figure, we have x sub 1, which is also equal to dun sa ating x sub l, x sub 2, which is also equal dun sa x sub u natin. Yung y sub 1 natin, equal siya sa f of x sub l, and yung y sub 2 natin, equal naman siya sa f of x sub u. So, mula dyan, substitute lang natin siya dito. So, we have y minus f of x sub u is equal to f of x sub u minus f of x sub l over x sub u minus x sub l multiplied by the quantity x minus x sub u. So, dito class, mapapansin nyo dun sa figure, dun sa ating bisection method, para makapag-solve tayo ng x sub m, is kukunin lang natin yung average ng x sub l and x sub u. Dito naman sa false position method, ang kailangan natin gawin is to connect the points of f of x sub u and f of x sub l, and kung saan nag-pass yung line natin sa x-axis, yung point na yun, kung saan siya nag-cross dun sa ating x-axis, that will be our x sub m. And that is, yung x sub m natin ay mako-compute natin siya gamit itong equation na to. Kaya nga lang, kailangan pa natin itong i-simplify. So, simplifying this equation, we have to substitute y is equal to 0 kasi dito sa x sub m naman natin, di ba, yung y natin dito ay 0. And yung x naman natin is actually x sub m. So, since the line intersect the x-axis at x sub m, di ba? So, mula dyan, substitute lang natin. So, we have negative f of x sub u is equal to f of x sub u minus f of x sub l all over x sub u minus x sub l multiplied by quantity x sub m minus x sub u. So, i-simplify lang natin to. So, rearranging the second equation yields the false position method formula. So, ito na yung ating false position method formula natin sa x sub m kapag false position ang gagamitin natin. So, we have x sub m is equal to x sub L multiplied by f of x sub u minus x sub u multiplied by f of x sub L all over f of x sub u minus f of x sub L. So, ano ba yung step-by-step procedure to perform false position method? So, ito yun, class. So, first, we have to solve for the values of f of x sub L and f of x sub u. Next naman is kailangan nating ma-determine yung value of the middle point, middle point, which is x sub m. Kung saan, yung formula nga niya is itong nakuha natin kanina. Ito siya. So, after makapag-solve ng x sub m, makakapag-solve na tayo ng value ng ating f of x sub m. Pagkayari nun, we have to choose new interval for the next iteration. So, paano ba tayo pumipili ng ating new interval? So, dito, mapapansin nyo, kaparehas lang siya dun sa ating bisection method. So, ang titingnan lang natin is kailan ba o saan ba nagkaroon ng opposite na sign at kung less than ba siya ng 0. So, yung product ng f of x sub L, f of x sub m, or f of x sub m and f of x sub u. So, yung product ng mga yun is less than 0. So, tingnan natin. So, choose the new interval for the next iteration if f of x sub L and f of x sub m are opposite in sign, or f of x sub L multiplied by f of x sub m is less than 0. So, the new interval will be x sub L and x sub m. It only means that x sub L retains the lower limit and x sub m will be the new upper limit of the interval. If f of x sub m naman and f of x sub u are opposite in sign, or f of x sub m multiplied by the f of x sub u is less than 0, so the new interval will be x sub m and x sub u. So it only means that x sub m will be the new lower limit of the interval and x sub u retains the upper limit. So repeat the first 4 steps for every new interval until it becomes relatively small and the approximate value of the root can be accepted. So, ulitin lang natin yung step 1 to 4. And then, for step 5, lahat na makukuha nating value, mas maganda kung ipipresent natin siya in tabular form para mas madali nating makita kailan ba nagkakaroon ng pagbabago dun sa mga sign and mas madali nating makita kung nagkakaroon pa ba ng changes dun sa mga values natin or na-reach na natin yung hinahanap natin na roots. So, para mas madali nating mas maintindihan itong false position method, let's have an example. So, sample problem. Find the root of an equation f of x is equal to x cubed minus x minus 1 between the interval 0 to using false position method. So, ang kailangan lang natin gawin is magkaroon ng first iteration. So, dito, given naman na yung ating first interval, which is the lower limit na 0, upper limit na 2. So, ang kailangan lang natin gawin is mag-solve ng f of x sub L and f of x sub u. So, mula doon, kailangan lang natin i-substitute yung 0 natin dito. Pag na-substitute natin yun doon, makakapag-solve na tayo ng f of x sub L and that is negative 1. Para naman dun sa upper limit natin, substitute lang natin yung 2 sa lahat ng x dito. So, ang makukuha natin f of x sub u is 5. So, dahil meron na tayo ng lahat ng values na kailangan natin para makapag-solve ng x sub m, so, plug in lang natin to dito sa ating given formula. So, we have x sub m is equal to x sub L, which is 0, f of x sub u, which is 5, minus yung ating x sub u, which is 2, multiplied by f of x sub L, which is negative 1, divided by ating difference ng f of x sub u and f of x sub L. which is yung f of x sub u natin, that is 5. F of x sub l naman natin is negative 1. So, mula dito, masolve natin class na yung ating x sub m is 0.3333. Dahil mayroon na tayong x sub m, of course, makakapag-solve na tayo ng f of x sub m, which is negative 1.2964. So, mula sa lahat ng f of x sub l natin, f of x sub u, and f of x sub m, so nagkaroon ng pagbabago ng sign. So, dun yun sa u at saka sa m. So, since f of 2 and f of 0.333 are opposite in sign, so the new interval is 0.333 and 2. So, mula dyan, pwede na tayo magkaroon ng second iteration. So, sa second iteration natin, yung ating middle x kanina, middle point, siya yung magiging lower limit at mareretain ng ating upper limit yung kanyang pagiging upper limit. So, dahil kompleto na tayo ulit ng mga values dito, plug in lang natin siya sa formula ng x sub m, and then makakapag-solve na tayo ng x sub m. So, dito, ang x sub m natin is 0.6765. So, dahil meron na tayong x sub m, makakapag-solve na tayo ng f of x sub m, which is negative 1.3669. So, again, since f of 2 and f of 0.6765 are opposite in sign, the new interval is 0.6765 and then 2. So, dito class, mas madali itong sundan kung magsosolve din kayo ng sarili nyo. So, dahil recorded na nga yung binibigay ko ngayon, so pwede nyo itong i-pause and then try nyo din mag-solve para mas madali nyo masundan. So, dahil na-rin na tayo sa second iteration, punta na tayo dito sa ating third iteration, kung saan gagamitin na natin na bagong lower limit yung na-solve natin na x sub m kanina and yung f of x sub m. And then again, yung ating upper limit, parehas pa rin siya. So, we have x sub l, that is 0.6765, f of x sub l, which is negative 1.3669, and then yung upper limit natin, so we have x sub u, which is 2, and yung f of x sub u natin, which is 5 pa din. So again, dahil kompleto na tayo ng mga values, plug in lang natin siya dito sa formula natin ng x sub m. So mula dito, makapag-solve tayo class ng ating bagong x sub m, which is 0.9606. So, dahil may x sub m na tayo, makakapag-solve na tayo ng f of x sub m natin, which is negative 1.0742. So, again, nagkaroon ng pagbabago ng sign. So, dito ulit sa ating middle point and dito sa ating upper limit. So, since f of 2 and f of 0.9606 are opposite in sign, so the new interval is 0.9606 and 2, which is gagamitin naman natin ulit for our fourth iteration. So, sa fourth iteration natin, yung na-solve natin na x sub m and f of x sub m will be our new x sub l and f of x sub l. Yung upper limit natin, the same pa rin siya. So, from this table, kompleto na naman tayo na values para makapag-solve ng bago nating x sub m. So, plugging these values to this formula, we have x sub m is equal to 1.1444. So, dahil meron na tayong x sub m, makakapag-solve na tayo ng f of x sub m natin, and that will give us negative 0.6456. So, since f of 2 and f of 1.144 are opposite in sign again, so the new interval is 1.144 and 2. So, paulit-ulit lang siya, class. So, pwede natin siyang ilagay in tabular form. So, dito, mapapansin natin, after 20 yet na iteration, makukuha natin value for x sub l is 1.3247, x sub m is 1.3247, and yung x sub u natin is hindi nagbago, 2 pa din siya. yung ating f of x sub L is na-reach niya na yung 0, ganun din sa f of x sub M natin. Yung f of x sub U natin, di pa din siya nagbago, and that is still 5. So, at the end, our new interval is 1.3247 and 2. So, dito class, isa sa characteristics ng false position method is yung isang kanyang limit, pwedeng x sub L, pwedeng x sub U. So, mula umpisa hanggang sa dulo ng iteration natin is the same. So, dito sa given na formula na, given na equation natin, sa x sub U siya nagkamukha-mukha. So, yung f of x sub U natin din is pare-parehas din. Pero, may mga equation naman na dito tayo sa x sub L pare-parehas and dito sa f of x sub L. So, huwag kayong, so kapag ka ganun yung nangyayari, kapag ka nagsosolve kayo, so ibig sabihin lang nun is tama naman yung nakukuha nyo. Kasi hindi siya nag-diverge. And since yung false position method natin is under pa rin sa bracketing method, so ang mangyayari and kadalasan na nangyayari is nagko-converge siya talaga. So, dito class, paano natin malalaman kung alin dito yung ating roots ng ating non-linear equation? So, saan ba tayo mag-i-stop? So, andito na ba siya sa table, yung sagot? So, dito class, para sa false position method, para makakuha tayo ng ating roots, so, ang kailangan pa rin natin gawin is gamitin yung ating formula na x sub M kanina. So, dito, after 20th iteration, ang interval nga natin is 1.3247 at saka yung 2. So, ano ba yung f of 1.3247 natin? So, that is 0. And ang f of 2 naman natin is 5. So, dahil kompleto na tayo ng mga values, plug in lang natin siya dito sa formula na to. So, we have 1.3247 for x sub L. We have 5 for f of x sub U minus yung ating x sub U, which is 2. Yung ating f of x sub L, which is 0. So, i-divide lang natin siya. And then, kunin natin yung difference nito, f of x sub U natin and ating f of x sub L. So, solving this one, that will give us x is equal to 1.3247. So, mula dito, yun pa lang natin masasabi that the root of the equation na f of x is equal to x cubed minus x minus 1 is 1.3247. So, ang kaibahan lang niya dun sa bisection method. So, pag nakuha natin yung interval dun sa may dulo, kunin lang natin average, that will be the root. So, dito naman sa false position method, parang ganun din siya, kaya nga lang, iba of course yung formula nung ating x sub M. Or formula natin dun sa pagkuha ng ating root. So, paano naman kaya kapag ang tanong is until 7th iteration lang? So, kapag ganun yung tanong, until 7th iteration lang, so ang kailangan lang natin gawin is kuhanin yung ating new interval. After natin makuha yung ating new interval, solve lang natin yung f of x sub L niya and f of x sub U. So, mula doon, makakapagkuha na tayo ng mga values and makukompleto natin yung mga hinahanap para makapag-solve tayo ng roots. So, substitute lang natin yung mga values na na-solve natin. So, mula dito, ayan. So, after 7th iteration, the new interval is 1.3091 and 2. So, ang f of 1.3091 natin is negative 0.0655 and yung f of 2 naman natin is 5. So, plug in nga lang natin itong mga values na to dun sa ating formula. We can solve that our x or yung root natin after 7th iteration is 1.3093. So, medyo malayo siya dun sa nakuha nating value after 20th iteration. Pero kung ang required lang sa atin dun sa problem is 7th iteration, so okay lang to. Yung 1.3093 na nakuha natin. So, yun yung paraan ng pag-solve gamit yung ating false position method. So, this method is usually faster to converge than the bisection method. So, mas madali daw nating ma-determine yung value ng ating root compare dun sa bisection method. But this is not ideal, especially when the initial interval is large. For example, if the difference between XL and X sub u is greater than 3. So, kung ang interval natin is 0, 4. So, mas mahirapan tayo sa pagkuha ng ating roots. So, the difference between bisection method and false position method is that in bisection method, both limits of the interval have to change. This is not the case for the false position method, where one limit may stay fixed throughout the computation while the other guess converges on the root. So, yun nga yung in-explain ko kanina dun sa table kung saan yung x sub u natin and yung ating f of x sub u is hindi nagbabago. So, isa siya sa properties or characteristics ng false position method. So, compare dun sa bisection method natin, parehas pa bago-bago yung x sub u and yung x sub l natin. So, dito, kapag false position method, kapag medyo nagbago na yung sa isa, so medyo masisense mo na kaagad na may mali dun sa computation mo. So, dito naman na tayo sa introduction dun sa open method. So, dito sa open method, so sabi dito, okay, so sabi dito, finding the roots value using the open method starts by assuming an initial value of x or x sub 0. And series of iterations are performed so that the value of x becomes as close to the actual roots as possible. So this method means advantage compared to the previous one is this only needs one initial value x. So, compare nga dun sa ating bracketing method. So, meron tayong initial value na dalawa, which is yung ating mga interval. So, dito, isa lang. So, sabi din dito, mas mabilis daw mag-converge pagka open method yung gamit natin. However, the value of x do not always converge. Some of the open methods are Newton-raphson method and second method. Yun nga lang daw, kapag sa open method, may chances na mag-diverge yung ating solution or yung computation natin para makuha yung roots ng isang non-linear equation. So, dito, meron tayong dalawang method. Yun nga yung Newton-raphson at yung ating second method. So, compare lang natin si open method dun sa ating bracketing. So, in bracketing methods, we use two initial guesses and the bounds converge to the solution. In open methods, we need only one starting point or two that not necessarily bracket the root. So, these methods may diverge contrary to the bracketing method. But when they converge, they usually do it much more quickly than bracketing method. So, dito sa open method, may chance na mag-diverge yung ating computation. And kung hindi naman siya magda-diverge, mas mabilis naman daw siya compare dun sa ating bracketing method. So, here are some notes para sa open method. So, the idea of this method is to consider at least one initial guess which is not necessarily bracket the root. Normally, the chosen initial values must be close to the actual root that can be found by plotting the given function against its independent variable. In every step of root improvement, x of r of previous steps is considered as the previous value of the present step. In general, open methods provides no guarantee of convergence to the true value. But once it converges, it will converge faster than bracketing method. So, dito din sa open method, nagkakaroon tayo ng differentiation. So, umpisahan na natin dito sa Newton-raphson method. So, ang sabi dito, the most common and accurate root finding technique is the Newton-raphson method. So, this method involves the use of the slope of the tangent to the curve. So, consider the graphical illustration of this method as shown in the figure. So, we will let x of n as the last assumed value of the root x sub n plus 1 is the intersection of the tangent line to the curve at this equation. So we have the point slope form for this one. So we have y minus f of x sub m n is equal to m multiplied by quantity x minus x sub m. So yung m natin class is yun yung slope natin. So dito, kinukuha natin yung tangent, slope of the tangent to the curve. So the coordinate of the point where the tangent intersect the x-axis is x sub n plus 1 and 0. And from differential calculus, its slope is f of prime of x sub n. So substituting these values in the previous equation, we have y minus f of x sub n is equals to m multiplied by quantity x minus x sub n. Substitute natin yung 0 and yung xn plus 1. So we have 0 minus f of x sub n is equal to f of prime of x sub n multiplied by quantity x sub n plus 1 minus x sub n. So isolate lang natin yung x sub n plus 1. So meron na tayong formula. So that is x sub n plus 1 is equal to x sub n minus f of x sub n over f of prime x sub n. So ano ba yung procedure para ma-solve natin ang isang equation gamit yung Newton-raphson method? So ang kailangan lang natin dito class is magkaroon tayo ng initial given na x sub n. So isa lang ang kailangan natin na initial na given. So first, we have to determine the first derivative of the function, which is f of prime of x. So, pagyayari nun, solve for f of x sub n and f of prime of x sub n. Pagkayari, solve for the new value of x and x n plus 1. X sub n plus 1. So, ito yung formula natin para makapag-solve tayo ng value ng x sub n plus 1. Pagkayari nun, repeat lang natin yung step 2 and 3 for every new value of x until its value can be accepted as the root. So, parang mas simple na yung procedure dito sa ating Newton-raphson method. Pero para mas madali natin maintindihan, of course, sample formula muna tayo. So, dito, same, parehas pa rin ang ating sample problem. So, find the root of an equation, f of x is equal to x cubed minus x minus 1 using the Newton-raphson method. So, dito, sabi, use x of o is equal to 0. So, ang initial natin na guess or initial natin na given is x of 0 is equal to 0. So, ano ba yung una natin kailangan gawin? So, kunin lang natin yung derivative, first derivative ng ating given equation. So, ang given equation natin is x cubed minus x minus 1. So, ano ba yung derivative na to? So, that is 3x squared minus 1. So, for our first iteration, consider natin na x of 0 is equal to 0. So, paano yun? Substitute lang natin yung 0 class dun sa ating f of x. So, substituting 0 dun sa ating f of x, we have negative 1. Pagkayari nun, substitute naman natin yung x sub 0 natin dun sa ating f prime of x. So, mula dun, makakapag-solve tayo na f prime of 0, that is negative 1. And dahil dun, kompleto na tayo ng values para makapag-solve ng x n plus 1 natin. So, substitute natin yung nakuha natin na negative 1 para sa f of 0. And then, yung f of prime of 0 natin, negative 1 din. And yung x of 0 natin, which is 0. Okay? So, x sub n natin, yung initial. So, that is 0. Yun yung x sub n natin dito. So, mula dyan, class, makapag-solve tayo na x sub 1. So, that is negative 1. So, that's the new value of our x. So, dahil meron na tayong bagong value ng x natin, kailangan lang natin gawin, yung na-solve natin yun na yun, is siya yung isa-substitute natin dito sa mga equation natin. Sa f of x and f of prime of x. So, substituting the new value of x, that is negative 1, we have f of 1 is equal to negative 1. And then f of negative 1 natin, so ito class is f of negative 1 and this is f prime of negative 1. So that is equal to 2. So dahil kompleto na tayo ng value ng f of x sub n natin and f of prime of x sub n, and then may x of sub n naman tayo which is negative 1. Substitute lang natin yung mga values na yon. So we have x sub 2 that is equal to negative 0.5 which is the new value of our x. So mula dun sa new value of x natin, siya na yung magiging new x natin dito. So substitute natin yung negative 0.5. So, negative 0.5 siya. Substitute lang natin yung negative 0.5 dito sa lahat ng x ng ating f of x and then sa lahat ng x dun sa ating f of prime of x. So, mula dyan, makapag-solve tayo ng f of x sub n which is negative 0.625 and then f of prime of x sub n which is negative 1.75. So, yung x sub n natin class, ito, negative 0.5. So, perform lang natin to. Makakakuha tayo ng bagong value ng x natin which is negative 0.8571. So again, pwede pa natin ituloy yung iteration pero dito i-present na lang natin siya in tabular form. So for fourth iteration, continue lang natin. We have x sub n is negative 2.03846. So mula doon, makapag-solve tayo f of x sub n. And then, substitute lang natin uli, magkakaroon tayo na f of prime x sub n. And then, magkakaroon tayo na x of x sub n plus 1. So, tuloy-tuloy lang natin yung computation. So, mapapansin nyo, after nung 19th iteration natin, makakakuha na tayo ng value dito. So, compare dun sa bracket method, kailangan pa natin isolve yung ating roots by sa bisection, so average. Sa false position naman, gamitin natin yung formula ng x sub m doon para makapag-compute tayo ng roots. So, dito sa Newton-raphson method, kung ano yung value, last value class ng x sub n plus 1 natin, that will be the roots. So, hindi na natin kailangan mag-solve. So, kung ano yung dulo, dun sa x sub n plus 1 natin, huli natin na-solve, that will be the value of our roots. Okay? So, paano naman kung ang tanong is after lang ng 7th iteration? So, after 7th iteration, so, makukuha lang natin ay negative 1.4278. So, masyado siyang malayo. Diba? Dun sa ating actual na value. So, dito, mas mahaba yung ating magiging mga iteration. Or, pwede din naman, i-specify natin dun sa problem. So, after halimbawa lang ng 10th iteration, so, ang makuha natin na x sub n plus 1 is negative 1.7069. So, kahit malayo siya, pwede siguro accept. Pero, kung sobra naman nalayo, like this one talaga, so, kailangan talaga natin siguro paabutin up to 19th iteration or kung saan siya talaga malapit dito sa ating value. So, ito naman kasi class, di ba, nasusolve nyo naman to, nasi-shift solve nyo naman to sa calculator nyo. Tama ba? So, from there, makakapag-check naman talaga kayo kung malapit na ba yung mga values na nakukuha nyo doon sa ating table. So, the obtained value of the root using this method is much more accurate than using the first two methods for the same number of iteration. Thus, this method is most preferred in root finding method. However, the only downside of this method is that the solver needs to establish first the first derivative of the function. Kasi kapag ka na mali ka na dun sa first derivative mo, of course, mali ka na sa lahat. Some instances show that this process is complicated. So, merong mga false may mga cases na hindi din tayo kaagad nakakapag-solve or nagda-diverge dito. But we will not discuss it na lang And then mag-focus na lang tayo or pili na lang ng mga equations na hindi naman ganun kaagad or hindi magda-diverge. Okay? So, doon na lang tayo. Ang mahalaga naman is malaman nyo yung procedure in solving roots of nonlinear equation using Newton-raphson method. So, that will be the end of our Unit 4, Part 2. So, for Part 3, ang i-discuss naman natin is yung last method under open method in determining roots of nonlinear equation. So, that is the second method. So, second method is improvement ulit ng Newton-raphson. So, that will be discussed next meeting. So, thank you for listening, guys. So, thank you for listening, class. Okay, bye.